Hi everyone, I hope that you are staying safe and you're at home and you're doing okay. This week we were looking at some different experiments talking about force and mass and acceleration and what is going on with these three. So I figured I would walk you through it. I'm going to give you some examples and then I'm going to go through the videos that we all watched together this week. So let's see what we do. So, Okay, so the first thing that we started looking at in experiment number 1 is what happens when I apply different amounts of force to the same object. So when I was thinking about this, I thought back to when I was in high school. I played soccer. I was on the soccer team. There were times when I needed to move the ball around somebody, so I needed to kind of be gentle with it, and then there were sometimes I just needed to give it a big kick and get it as far away from me as possible. So in each of these instances, I'm using a different amount of force. For those small little kicks trying to get around somebody, I'm not using a ton of force, whereas that big kick to get it away, I'm using a lot of force there. So when I started thinking about that, I wanted to think about what happens when I give those different amounts of force, right? So if you're playing a sport and you give a gentle tap, kind of soft and easy, versus a big tap, what does that look like, right? So trying to think about that, think about how quickly the ball is often moving with that, and I kind of came up with these ideas that like when I gently tapped something, it generally didn't move as fast, whereas when I really gave it a lot of force quickly, it went really fast. And so there's some other ideas there, but let's see if we can make this line up with what we're seeing to the carts, right? So I just put in the videos that you were supposed to watch. I'm going to pause at some different points, right? So here we've got our two different carts, and what we've done here is we've just put some fans on top of them. So the fans are going to be what's giving me the force. This blue cart has 4 batteries in it, right? So it's got the power of 4 batteries. So it's got more force than this red cart with just 2 batteries in it. Right, so from that, we're going to look at what happens when this individual removes this meter stick and see what happens to the velocity, so how quickly these move. So let's see if we can see that. Right, so they're going to release, right? That's pretty much the whole experiment, right? This blue cart, remember this is the one with 4 batteries, so it has more power. And the red cart with half the batteries has less power. And what we can see here is that these carts are exactly the same. The only thing that's different is their number of batteries. And actually, even in fact, this red cart has like fake batteries in it so that they weigh the same amount as well, right? So we're just looking at how much force we give over what's going on. So we can see that this blue cart, in blue up here, speeds up a lot faster, right? We have an increase in velocity, a very quick increase, right? Because we see this steeper line, right? There's a greater slope here than down here with our red cart, which is in purple, unfortunately, right? We still see this increase, right? The red cart is still moving, but it's going a little slower, right? So we're kind of trying to come up with an idea of what the relationship would be. So the more force, the greater the velocity, right? That's kind of what we're seeing. What I really struggled with is thinking about the opposite. What happens when it slows down? I thought about this a lot this morning. So this is the example I came up with, and I don't know 100% if it's going to make sense. So if you have a question or it doesn't make sense, go ahead and leave a comment or message me on Schoology or email me, and I will try again. So let's say you're rushing to your different classes and you run into somebody in the hallway, right? You're starting in the gym and you need to make it all the way over to Miss Wedgwood's Spanish class, or maybe even farther than that, right? So you're rushing to your class, and let's say you run into one of the big guys on the football team, right? They're a large force, right? So if you run into them, how quickly do you slow down or stop, right? And in general, you stop pretty quickly. You might even be pushed back a little bit because it's really strong. But if the same thing happened and you ran into a smaller person, right, like, or maybe you're at home and you ran into a sibling who's younger than you, right? When that happens, you slow down a lot slower, right? It doesn't take as much to slow down. You might even keep going forward at first instead of slowing down, right? So we see these different ideas of if I run into a big force, I'm going to generally slow down faster than if I run into a small force, which is what we see with the carts, right? So we have pretty much the same setup here where we're going to be seeing these two carts. The blue one has more force, the red one has less force. we're really flipping upside down what we see, right? So if we're looking here, this gets a little confusing because this is our equal force, and it's at this point that we're really looking, right? We're looking at the velocity as it goes down between the blue and the purple. And remember, it's just going down because it's moving towards the motion sensor as opposed to away from it. But what we see here is this blue cart with more force. It had 4 batteries, so it had greater power. We see a steeper curve, right? It slowed down faster. Just like in the hallway, if you ran into a big person, you're gonna slow down faster, you're gonna stop, you might even go backwards a little bit. When we run into a smaller person, when there's less power, we still slow down, but we go a lot slower, right? So maybe you run into somebody the same size and you kind of slowly go back and forth, right? So in general, what we're seeing is whether we're speeding up or we're slowing down, or if we're speeding up or slowing down, we can see that the greater the force, the faster that happens. The more force I put into something, the faster it speeds up. The more force I put towards stopping something, the faster it slows down. All right, so that was all of experiment 1. Experiment 2 kind of flips the script on us. So what happens when I apply the same amount of force, right? So I'm using the same amount of force, but I have objects of different masses. And there are 2 ways that I thought about this. One of them you might feel more comfortable with than the other one. So let's say that I have 2 cars and I have to move them 20 feet because I won't start. So if I use all of my force, if I use all of the power that I can to push these cars, and these are my 2 cars, I got this little silver car and this big red and white truck, which one am I going to be able to move faster with the same amount of force, right? Like, logically thinking, I'm going to be able to move this silver car, which is smaller, it has a smaller mass than this big red truck. For some people, that might be a little difficult to think about. So if you, on the other hand, are going to go on a run, I've been running a lot during quarantine to try and stay healthy. If I'm running without anything on me, I'm going to be able to go pretty fast. I'm going to be able to pick up speed and get going. However, my significant other and I wore a backpack like this going through the Scottish Highlands last summer. It was really heavy, and all of the time I was noticing that people without backpacks on were passing us all the time, right? So when I have more mass, it's harder for me to speed up. It takes longer for me to speed up. That's true when I'm pushing the cars. It takes longer for the red truck to get moving than the silver car. It's true if I'm carrying something. It's more energy if I put extra weight on me than it is if I have no weight on me. So let's see if we can see this happening with the carts that we saw in the video. All right, so again, this time you will notice that the carts have 4 batteries each, right? We're talking about the same force, the equal amounts of force. We're not talking about somebody who is a bodybuilder versus your 2-year-old cousin pushing cars. We're talking about the same bodybuilder, the same individual. But what we're doing is maybe the bodybuilder had the truck with the extra mass, or they had the car with no extra mass. Or if you're running, no extra mass, or maybe I sent you with a big backpack of food. So what we see here as we play this is as we lift up on the meter stick, we're going to be able to see that this blue car, remember that's the one without any mass, any extra mass, is going to be able to go faster. Just like if I were out running and I don't have anything extra with me, I'm going to be able to speed up and go faster. Whereas this one, maybe your backpack is full of stuff like your laptop from school, or maybe some textbooks, or your lunch, or all of your gear for practice after school. It's going to take a little bit more time and effort. It's going to speed up slower, right? So if I have different amounts of mass but the same force, at least with speeding up, we see that the lighter one is going to speed up faster. Let's see if we can reverse that. So what if I'm trying to slow things down? I had a really hard time coming up with an example for this one, y'all. So hopefully this makes sense. So I thought about dodgeball. I don't even know if you all still play dodgeball in PE class. Maybe this is something from my childhood that is just like aging me and you have no idea what I'm talking about. But if you're playing dodgeball, right, instead of using, Mr. Ragland has decided this is what you're doing in PE. Instead of using one type of ball that's all the same, he decides he's going to pull out whatever types of balls that they have in PE. So he brings out some ping pong balls, little white ones, and he brings out some bowling balls. So if I were to throw them at you, and you needed to stop them, right? You don't want to get hit with, well, you probably don't mind getting hit with a ping pong ball, but you definitely don't want to get hit with a bowling ball. I have to slow them down, right? So if I am the person slowing them down, I'm the same force. Which one am I going to be able to slow down faster? Which one am I going to be able to stop faster, right? That's really what we're asking here. And I hope that if you think about it, you can stop a ping pong ball pretty quickly, right? You just grab it and it stops. But if I'm trying to stop a bowling ball, I'm going to have to put a little bit more, it's going to take more time for me to stop it. So let's look at these carts as well. All right, so we have that same experimental setup where the blue one has no mass and the red one has extra mass. And what we're going to see happen is they're each going to get a push and then they're going to come backwards, right? So they were given the same amount of force, right? They were both pushed with the same amount of force, which is what we're keeping consistent this time, but they have different masses. So as the fans are slowing them down, we can see that the blue one, the lighter one, the one with the lower mass, is decreasing. It's slowing down faster. It's got a steeper slope than the one with the extra weight on it, the one with the red on it. So that's kind of what we saw in our experiments this week, what we're looking forward to. We're going to do some summarizing questions next week in our collaborative groups, so hopefully you'll get lots of feedback. Then we're going to do the scientist reading, reiterate all of these ideas, and then we're going to look at some of the math of it. So we're not going to just leave you here. We're going to keep going forward. I know you all can do this. Again, if you have questions, comments, let me know. All right, good luck, y'all.